Let's get started. In hardware interrupts, actually we have two instructions related to interrupts. That is the basically controlling of the interrupt, or how we can mask a particular interrupt, or how we can check the status of the pending interrupts. So there are two instructions related to this. That is the sim set interrupt mask and rim. Okay, so one instruction sim, basically these two instructions execute on the basis of the content of the accumulator, in which all the bits of the accumulator will specify some conditions. Okay, so if we include the sim instruction in our program, so by checking the status of the bits of the accumulator, we may give some conclusions. So see here, sim instruction, by using this instruction interrupt can be masked. Means we have five hardware interrupts, out of which trap is unmaskable, so we cannot mask the trap interrupt. So there are other interrupts 7.5, 6.5 and 5.5. okay, so if the accumulator bit D0 is set, if the D0 bit of the accumulator is set and we include the sim instruction, that means RST 5.5 to be masked. If the if there is any incoming interrupt that is RST 5.5, it can be masked. Okay, if D1 bit is 1, we can mask RST 6.5. If D2 bit is 1, we can mask RST 7.5. okay, here the D3 bit of the accumulator describes basically interrupt enable. Okay, so if we want to set the interrupt enable flip-flop, okay, that is the EI instruction is included. So if we set the D3 bit to 1, interrupt process is always enable. Okay, and if D3 bit is set, then interrupt process will be enabled and flip-flop will get set. That is interrupt process is enabled. Okay, D4 bit represent the basically RST 7.5. so RST 7.5, to reset the RST 7.5 interrupt, we may set the D4 bit to 1. okay, D5 is don't care condition. D6 is basically SOE, serial data transfer process enable. okay, by setting the D6 bit to 1, we are enabling the serial data transfer mode, and the if D7 bit is 1, serially data can be out. So we have seen in the architecture or pin diagram of the 8085, we have two pins for serial data transmission. There is SOD pin and SID pin, serially out data and serially in data. okay, so sim instruction, basically this instruction is used for serially out data through the SOD pin, and the rim instruction is used for serially in data into that is D7 bit of the accumulator. okay, so again I'm describing or illustrating some of the things of the set interrupt mask. By using this instruction, interrupt process can be masked. okay, so how many interrupts we can mask? RST 5.5, 6.5 and 7.5. and to reset the RST 7.5, which bit of the accumulator should be set to 1? D4 bit of the accumulator. okay, to enable the interrupt process, or to set the interrupt enable flip-flop, which bit of the accumulator is set to 1? That is D3 bit. okay, so remember the pattern of the accumulator, which bit represents which particular process of the interrupt. Next instruction is rim, read interrupt mask. okay, so this instruction basically specifies how many of the interrupts are pending to come into the program and how many of them are marks. okay, and also this process enables serially in data through the D7 bit of the accumulator. Means the content of accumulator we will check always, and check the individual bits status, either it is 0 or either it is 1. okay, and we may give some conditions for execution of the rim instruction. So rim instruction, to find out status of the pending interrupts, means how many interrupts are going to include into the program. To find out status of the marks interrupts, we may check the status of the marks interrupts. Okay, and this instruction is used for serial transfer of data through SID pin. So serial in of the data through SID pin. And both the instructions sim and rim has no operand. Instruction word size will be 1 byte, and machine cycle will be just fetch. Addressing mode will be implicit. Okay, so see the bit pattern of the accumulator to execute the rim instruction. D0 bit, if it is 1, RST 5.5 is marked. D1 1, RST 6.5 is marked, and similarly D2 is 1, RST 7.5 is marked. Okay, and here again we have D3 bit as interrupt enable bit, that is the interrupt process is enable or interrupt enable flip flop is set. And after D3 bit, D4 I 5.5 means if this bit is 1, that is D4 bit is 1, RST 5.5 is pending, means it is still we are still waiting for this interrupt to come into the program. And similarly D5 I 6.5 and D6 I 7.5 means D4, D5 and D6 bits represent pending status of the RST 5.5, 6.5 and 7.5. Okay, and last bit of the accumulator, that is D7 bit, always if it is 1, it enables the serial in of the data through SID pin. Okay, so we conclude here